Okay, we're ready to acquire some data here. And what I want to do is, now remember, we're going to capture a pulse train. And the time between these pulses, like this, there's a pulse 1, pulse 2, pulse 3. That should correspond to 2 travel lengths because the microphone's at one end of the pipe. So the pulses are traveling back and forth, getting reflected at each end. So remember that each pulse corresponds to twice the length, and we have to make that correction for the fact that the reflection actually takes place right outside the pipe. And I'll give you those dimensions, the length of the pipe and the acoustic lengths. Now, so I'm using a single trigger method here. I hope it works. See if it does. So here we go. Got it. That should work. Okay, now what we're going to do at this point is I need to rescale the amplitude so we can see what's going on here. There we go. Oh, those negative peaks look really good. And you can see how they damp out. Why is that? Because every time there's a reflection, you see that? Every time, okay, so that's the first pulse that hit the microphone. So then it travels 2L, next pulse, 2L, next pulse, then another 2L. You see, because some of that air is going out into the room. Some of the energy escapes, and you can see that nice damping. Almost looks like exponential damping. So what we need to do is we need to grab the cursor on the go use the status bar and go to cursor and go to value. Now this is the easy way. There's better ways to do this, but I want it to be transparent to you guys. Okay, so what we need to do is now I'm also going to do something else. I'm going to spread out the pulse train, see? And why did I do that? So that, wow, this stinks. I can't do, I'm going to have to leave it squinched up. It's not doing what it should do. There we go. Okay, so we'll just get about 6 of them. We won't have really high resolution, but it'll be okay. Let me spread it out a little more. Here, I'll use the zoom. Maybe that'll do it. There we go. Then I can move it around. Okay, here we go. So we need to record. Now, what you need to do is write these down. We're going to start here. We'll call this T0. And that's like, think of that as a triggering the microphone. And then we'll call this delta T1. That's the time between the first 2 pulses. So T0. So this will be delta T1, delta T2, delta T3, and so on. So let's do that. So we need to record the starting point. So I'm going to put that in the middle of that peak the best that I can. Okay, so there we go. Here's your time right here. Let's write that down. We'll call it T sub 0. T sub 0 equals 20.1538 millisecond at M right there. All right, let's grab this value bar and move it over to the next peak. Okay, there we go. So you need to be writing these down. Okay, the next one is what? We'll call this T1 equals, and I'll write them down by hand and just take a picture of it and send it to you too, so you can check yours. So this is what? 29.1538 milliseconds. So what did this tell us? This told us that the speed of sound, basically the speed of that pulse, it took it about 9 milliseconds to travel twice the pipe length, right? Twice the pipe length, because it hits the microphone, goes to the other end of the pipe, and then back to the microphone again. So that would be 2L. So it goes, and that pipe's roughly 1.5 meters. So that's going about 3 meters in 9 milliseconds. So roughly, we got to do it exactly. So that's just a rough estimate. Okay, here's T3. T3, T2. Why did I call it T2? Okay, this is T0, T1, T2, because these are going to be delta T's. Okay, T2 is equal to what? We're going to say it's 38.2308 millisecond. Okay? Now let's go to T3. Oh, now it's working. It's scrolling like it should. So some of this freeware is kind of goofy. It doesn't behave consistently. Okay, so we had 0, 1, 2. Here's T3. T3 is what? 47.2308 millisecond. Okay, T4. I could even zoom in more and get better resolution, but we're not trying to win a Nobel Prize here. We're just wanting to get some data so you can learn something. All right, here we go. T4 is equal to 56.2308 milliseconds. I like those 08s. Something about the discrete values here in this digital software that does that. Okay, here's T. Let's see. Yes, this would be T5. T5 is equal to what? 65.3077 milliseconds. I'm recording the right numbers. I might have made a mistake. Hell, I can't see. Getting old. All right, here we go. Now T6. This will be enough. This is getting stupid. All right, 74.3077 millisecond. Okay, now so you've acquired your data. I'll call this acquiring the pulse train, and then you'll know to go in here and you can get your data. All right, that's enough. Let's stop.